In this series of videos I'm attempting to repair and restore this Osborne OCC1 vintage computer. In the series so far I've carried out various repairs, mostly to the keyboard but also the disk drives. The main board had some RAM issues, a couple of other minor issues that I've put right, and it was booting up to the floppy disk. In fact, it still does boot to floppy disk, and it was apparently working fine. I still had a few issues to overcome, but the system could format disks, it could copy files, it could boot to any of the utility software. It was working reasonably well, but it developed this strange fault where it suddenly wouldn't format floppy disk. In fact, it wouldn't write to floppy disk at all, so you couldn't copy anything and you couldn't write any data to any of the disks. Now, it looked initially like it was a failed disk, but swapping the disk over or using a Gotek or a spare drive made no difference whatsoever. It did exactly the same thing. And I was working my way through trying to figure out what was going on, where it was failing. And one of the issues with the Osborne is it's a very difficult machine to work on, not because it's a complex machine. It's just the way it's physically constructed makes it very difficult to work on, because you've got this sandwich board arrangement and you just can't get to the parts that you need to. So to format a disk in this, for example, you boot to CPM, you put the disk in you want to format, and I'll go through the process and show you what we have to do. And just bear in mind that it was failing to format the disks. So I'll boot the machine up. So we've got the welcome screen on the display. There's a CPM boot disk in drive A. This is upside down, by the way, so drive naught, or the first drive, is the one on the right here. I've taken the other drive out just so I could access the signals more easily. As like I said, because of the way this is constructed, it's very difficult to get to certain parts of it. We'll now boot to CPM. I've got the keyboard down here, you can't see it, it's just at the off the bottom of the screen. Okay, so we've got the CPM prompt. Like I said, it's upside down, but hopefully you can see what's going on. And to format a disk on this machine, it's a bit odd. It's CPM, but it's still a bit of an odd implementation of CPM. CPM itself is very standard, but there are certain aspects of the way that Osborne implemented the CPM system that are a bit odd, and I suspect are part of what's causing the problem, but we'll come back to that later. So to format a disk, we actually use a piece of software that's on the disk. It's the copy.com command file. So we'll invoke that. So copy, hit return again. And so we're getting, you probably can't read it, but we're getting two options, or three. One is return will take us back to CPM, or we've got copy or format, and we want to format. And it's now asking us which drive we want to format, so I'll hit B. Now at this point it was going straight in and starting to try and format, which it shouldn't do. It should give us the option to go for a double density or single density format, and it wasn't doing that. It was jumping straight in and then failing. You'll see what it does as we proceed. So I'm going to hit B and now enter to start the process. But notice now it's come up with the expected menus asking us if we want single density or double density. So I'm going to hit D for double, and the way this works is it tries to write some data to the sector, it reads it back, and assuming that process works, then it puts an asterisk against each sector as it proceeds. If it fails, it puts an E against each sector that it couldn't successfully read the data back from. But notice now it's working. It's actually formatting the disk I've got in the drive. And we've just booted this up, haven't done anything else, booted it up, come into copy. We'll do it one more time, so we can come back in, repeat the process, asking us what density. We'll go for double, and it's working again. So it was odd, it wouldn't format at all, but it didn't just suddenly start working. It started kind of slowly recovering, where one or two sectors would start to succeed, but the rest would show an error, and then gradually the number of errors went away until we got to this situation. But I can now turn the machine off, reboot it, and it works fine. So what I'm going to do now is I'm going to switch the Osborne off. I'm going to take the disk out of the drive, put the disk back into the drive without doing anything else, and we'll reboot the Osborne and see what it does. So I've turned the Osborne off. We'll take the disk out of the drive. So this is the disk that we are formatting. Put it back in, close the drive up, and reboot the machine. Got the welcome screen. We'll hit return to boot to CPM. So that's CPM booted up. We'll invoke the copy. Format. It's asking us what density, and so that's working fine. So you can see we can reboot, we can do what we like, and it's succeeding. So we've taken the disk out, turned the machine off, turn it back on, and it's now I haven't done anything. I haven't repaired anything, I haven't changed anything other than taking the drive out, but that didn't fix it. It carried on doing the same thing. It was after that it started working again, but I haven't modified anything whatsoever. What I'm going to do now is return to CPM, and the machine's still powered up. We'll take the disk out of the drive, put it back in, try copy again, format, drive B, and so it's working fine. What we'll do now is put a different disk in the drive. Once this is finished, just let it finish first. You should be able to just swap the disk and format different disks. But we'll wait until this is finished, and then we'll put another old disk in here and see how it fares. Okay, so that worked fine. I'll now swap the disk that's in the drive. This is again the disk that we want to format. Put in another old disk. This is a used disk, but it is the correct type of disk. And now we'll try to format it. So that's failing. Okay, so it's unable to format this disk. We'll wait until it finishes. I'll put the original disk back in that we were just formatting, and we'll try it again. Just need to wait for this to finish. There is no easy way to exit this. They haven't implemented any key pickups to get out of the formatting process. Okay, so every single track failed. So we'll put the original disk back in that we were using. And we'll try formatting that disk again. Notice this time it's gone straight into trying to format, and now it's failing. So it's coming up with E now. Now this is the disk that we just successfully formatted a number of times, but now it's refusing to format it. And notice those tracks formatted, and it's failing, it's working, now it's succeeding. So depending on which disk I put in that fails, When I put a disk in that I know works, it's failed to format, but some of the tracks actually work, so we'll try that again. And this time it's asking us what density we want, so we'll say double, and this time it's formatting. As I was saying, depending on which disk I put in that fails, it may not recover at all, or it can take ages and ages to recover. I might have to go through this process 20 or 30 times before it starts to recover, but it does recover. And it makes fault finding very difficult. I started going through the code, but unfortunately it was failing in different places all the time. It was just failing in one place and another, and there was no consistency at the point at where it fails. So just to go over how this is implemented in this particular machine, because it is a bit peculiar. So CP/M is a fairly standardized operating system, one of the first standard operating systems. It's cross-platform compatible, so the core of it consists of a number of elements. We have the BDOS and CCP, so they're two parts that are part of CP/M, and they're fairly standardized. The BIOS is really a join between the hardware system that CP/Ms are running on and CP/M itself. So it's a series of standardized function calls, along with some functions that are specific to the hardware that it's running on. You also have the ROM, which is the monitor ROM on the main board, and that consists of the low-level functions to connect the BIOS to the hardware, and also you can call functions in the ROM directly. And then CP/M itself is loaded into the top of user RAM, and when you then run CP/M, it's running CP/M, and CP/M is making use of BDOS, CCP, the BIOS, and functions within the monitor ROM. Some functions are built into CP/M, so when you type them, it kind of looks up the location of the function. So there's a lookup table and pointer that are part of the particular CP/M implementation. But all the function calls are fairly standardized, as is the order that they are implemented in. But some functions are not built into CP/M, and the copy function that we're using here is one of those. It's a user program, so it's actually loaded into the bottom of RAM. Now, the bottom 100 hex bytes are reserved for use by CP/M, so any user programs are loaded in the RAM area from 100 hex up to the top of available free RAM. And so our copy program will be somewhere in this location. And as I went through the code using the logic analyzer, I could see these addresses being accessed, but bear in mind, one complication here is it's a multi-bank system, so we need to be sure as to which bank we're looking at. So what I did with the logic analyzer is I'm hooked up to the CPU, the Z80 CPU, but I also have another line here that's going to the chip enable line of the monitor ROM. That's this ROM. That's not the monitor ROM over there, it's just the monitor ROM's underneath this daughter board, but this the chip enable line comes from this chip. So I can use that on the logic analyzer to be sure that I'm reading from ROM rather than reading over here, which would of course in our case be the copy.com program. Unfortunately, I can't find the source code for the copy.com anywhere. I've been looking for a while now, but I can't find the source code for it. I've got a source code for the BDOS, CCP, BIOS and CP/M itself, but I can't find the source code for copy.com, so it makes it a bit complicated trying to do this. But that's where I needed to really be looking, because this weird behavior is indicative of something to do with the way that the code is implemented on this particular machine. And there are various complications with this. So I was going through using the logic analyzer, and I was tracing my way through the code. So I did video it, but I decided not to show it because it was kind of a long-winded, boring process. Let me know if that's the sort of thing you want to see. But I started off with a call to the format command, and that's done through a lookup in the BIOS. So there's a BIOS table, lookup table in the BIOS, and then it jumps into the code in the ROM that handles the low-level format. Now, it's not a format command as such. All it really does is it writes particular data to a single track, and that's called repeatedly by the copy.com program to do the actual formatting. So it writes the data to a particular track, and looking at the way it's running through the code, when it jumps back, it then jumps to the read sector function in the monitor ROM, and it's at that point when it fails that the formatting fails. So when it's trying to read back the data it's written to the track, that's the point at which it fails. Now, one thing that's really complicating this is that there's an interrupt running all the time that's for scanning the keyboard, and that code, the way this is written, this is part of the BIOS that was written by Osborne, and it kind of resides up here. Now, it really complicates the way the machine works, because that interrupt also handles certain aspects of the drive system. So the keyboard scanning, which we know there's an issue with, because of the way it's implemented, there's nothing smart in the keyboard, and all the leads going to the keyboard and through the keyboard itself are quite long. And normally you'd have some electronics on the keyboard, and then the lead itself is relatively immune to noise, but this arrangement is inherently going to cause problems. So the function that scans the keyboard is also partly responsible for the drive operation, and so I haven't tracked down what's going on yet. I'm still working on this, but I've got a feeling that part of this problem is related to the keyboard scanning. So what I'm going to be doing next is trying to provoke the machine into completely failing to format. So I'm going to put a few disks in until it gets upset and stops formatting continuously, and then what I'm going to do is try and format a known good disk. It will then start failing that as well, but when I'm formatting, I'm going to unplug the keyboard once I've got the process going and seeing if that causes it to recover. I've got a feeling what's going on here is that during the process there's a side effect somewhere, most likely introduced by the keyboard itself, or the way the keyboard's used and implemented, that is interfering with the writing to the disk. Now, it reads the disk fine because it kind of reads the disk into memory, and then it uses the bulk copy command in the Z80 to move it. So that is fairly immune to interference because it's kind of an automated process controlled by the Z80 itself. And as long as the main board is working fine, then that should succeed. It may be caused by the DMA system. We'll have to look into that later. But the writing to a disk is multi-step, and part of that multi-step process involves the keyboard scan code and circuits, so that may well have something to do with this. I'm hoping all this makes some sense, and like I said, the reason I'm not going through this with the logic analyzer and showing you this is because it would have taken probably an hour and a half or 2 hours to show what I've just tried to explain. It was only took about 15 minutes to actually go through all this, but setting up the camera and keep moving it back and forth would make a very slow explanation. So I didn't want to bore you with that, but in essence what I've just said I picked up using the logic analyzer, and as I went through the code it was failing in random places, and ultimately I found that the failures seemed to be related to the interrupt being generated for the keyboard scan. And it's a very small bit of code initially, but it jumps into a fairly lengthy code. But part of it is to handle the disk drive. Okay, so that's where I am so far. The next step, like I said, is to try and provoke the machine back into a continuous failure to format. And that's one thing that makes it difficult, is it recovers and then suddenly it's working again, and you've got to try and get it to not work again. And then you can carry on, but generally speaking at that point it's doing something slightly different. It's still failing, but it's failing somewhere else. And as I said, it's just a bit of an odd implementation, the way that they've gone about doing this. If you do have a copy of the copy.com source code, then please let me know, but otherwise what we'll do in the next video is try to go through the next stage in this fault finding, which is to try and get the machine to consistently misbehave, and then see if we can find what's actually causing that behavior. So just to clarify what's going on with this a little bit, this type of behavior it kind of looks a little bit like the parameters for the write going to the drive are incorrect. So maybe the write pulse or the write gate is too short or too long, or the timing's wrong. So what I've got hooked up now is I've disconnected the physical drive, and I've got a GoTech connected instead. It's configured so the machine will still think it's a physical drive, and I've just tried to format that, and it's doing exactly the same thing. It's failing on kind of random tracks. We'll try to repeat this. It's asking us what density we want, and it's coming up with errors. I don't know if you can read this or not. And then it's succeeding, and then it's failing, and then it's succeeding. So it's fairly random, but it's behaving in exactly the same way as the actual hardware floppy drives. So it's very unlikely to be timing or drive or supply. We'll try it one more time, simply because if that was the case, then the GoTech should be fairly immune to that. Now what is interesting is that with the GoTech it seems far more consistent on which tracks are failing. So it could be that the track identification is being corrupted by something to do with the keyboard, or it could be a fault on the main board where it's failing to properly identify the track. If it was just random data issues, then it's very unlikely that it would be the same tracks each time. It could be, of course, but I've done this 4 or 5 times now, and each time I've done it while you've been watching, it's exactly the same tracks that are failing to format. And now, as you can see, the tracks from this point on are formatting fine. So something strange going on, and at least if we can get some kind of consistency like this, then we can maybe look into it in a bit more detail. So what I'm going to do in the next video is use the GoTech, and because it's acting in a much more consistent way, albeit in an odd way in terms of the random nature or the semi-random nature of the failure to format, then we can start trying to investigate exactly what's going on.